Helicopters, always a popular topic here, and for good reason. Helicopters are just simply cool. This is the Sakari 8 helicopter, and it's a kit you can build. That's right, some assembly required. Coming up right now. So what do you need to know? It goes up, it goes down, it spins to the right or to the left, and oh yeah, it hovers. And this one is painted up like a Ferrari that just left Enzo's workshop. The mechanics of it all. Well, it's made up of a chrome moly steel tube frame with the cockpit totally wrapped in carbon fiber.
All right, everyone, we're here at Oshkosh 2024, and Keith is going to introduce a brand new product to the United States for us. At least it's new to me. So Keith, what's going on with this, and how do you play in the role of this helicopter?
Yeah, so this is the Sakari 8. This is the latest design from Sakari SA in Argentina. Sakari SA has been around a very long time. Augusto Sakari started when he was 19 years old. He moved to Argentina and is a self-taught engineer, self-taught pilot. He passed away a little over 2 years ago, or a little under 2 years ago, at the age of 85. His two sons run the company there. I partnered with the two sons to create a U.S. company so that we could bring these helicopters. This is one of 4 models that they build, and we wanted to bring those to the largest aviation market in the world here in North America. So I'm a helicopter pilot. I've been a helicopter pilot for 30 years. I've owned helicopters before. But when I started looking around to get another helicopter, the prices have doubled, of course, since I owned my last one. And this was very affordable. And what I loved about it was it's using a factory 915 Rotax turbocharged engine. So it's got more than enough power. I fly in Reno, which is a little bit higher density altitude. We have 6,000, 7,000 foot density altitude days. And this has more than enough power to accommodate me coming and going. It's a delight to fly. It feels like a go-kart. Payload, endurance, and sensitivity on the controls is probably similar to an R22 Robinson, but we burn auto gas, so we're buying pump fuel up to 10% ethanol, lot less expensive than avgas, a lot easier on the engine than avgas, and we're only burning about 4.5 to 5 gallons an hour in this machine, where R22 is around 9 or 9.5.
So you say in helicopter language they call these ships, I understand,
Ship,
right?
yes,
so most
ships.
Comparable flight characteristic would be the R22, you said?
I think so, yeah. Auto's a little bit more friendly in the auto rotation because we have weighted blades or carbon fiber blades, and the weights in them make it feel like it's a little bit greater mass, so it doesn't decay quite as fast on it when you cut the power. It also has no tendency to pitch like a Robinson does, so its sink rate is probably similar. You know, it glides a little farther than a 300, but probably about the same as an R22, I suppose.
Okay, so what is the main construction of this? It looks like you got a tube frame and then composite shell.
Take a look inside. There's, as I said, we use aerospace materials. All of the raw materials go to Argentina. They weld the airframes. These are 4130 steel. The carbon, they use carbon fiber for building the cabins and the blades, aluminum for the tail rotor and tail boom, and the transmissions are purpose-built transmissions, helicopter transmissions that they've been doing for probably 40 years, so a lot of time. The most copied thing in helicopter industry is a patent that Augusto Sakari did about 45 years ago for this type of rotor head, where the swash plate is below the transmission, and it makes it a very clean look, but it makes it very light because you've got and very strong. You have a hollow main shaft, so the control goes through the tube of the main shaft, and so you can make a thick wall, large tube as opposed to a heavy, solid, smaller shaft. It's not as strong.
All right, so let's get mechanical for a second, real quick. Let's follow through from like the propeller shaft normally, or crankshaft, to your, I guess, transmission, how it goes up and then how it goes out to the tail.
So the 915, like all Rotax, uses a gear reduction. So we have a specific configuration we use so there's no oil in the shaft, because we use on the drive pulley on the bottom, we actually have our clutch. That's a centrifugal clutch for engaging the drive system. So we do have two belts, redundant belts, that drive the engine power into the transmission system, the final transmission system, but that stays tensioned all the time. And the lower clutch is a centrifugal clutch. So when you start the helicopter, it's just like starting a turbine. Once the engine lights, the blades start to turn slowly, and at about 2,400 engine RPM, that clutch is locked up. And in the final drive, we have a sprag clutch, or an overrunning clutch, for auto rotation. So if you have an engine failure or lost some component of the drive system, or it locked up, you'd still be able to auto rotate safely.
Okay, and so that's going up. You got a couple, I guess, carrier bearings or whatnot that hold the shaft.
Here, we're a solid shaft to the rear. We've got a flex coupling here. It's a special steel, and it has redundant bolts. So there's two bolts that drive it, and then there's two pins through this, what looks like a rotor brake disc. Two pins in there to make sure that you still have rotor authority if you break a bolt. And so you might feel that and hear it a little bit, but you'll still have tail authority.
Okay, and then going up, you have your own fixture that holds all the torque loads of the rotors.
Yes, and it's a regular, as I said, a regular helical gear, purpose-built helicopter transmission, and the same with the tail rotor. These are CNC machine gearboxes, and a local company there in Argentina that's built their transmissions for the last 40 years.
Okay, so that shares the same shaft going back, and then you got another little gearbox at the end.
Yeah, so this is the anti-torque rotor. So anytime we're trying to have the engine turn, the rotor, and in most U.S. ships, it's counterclockwise. So that means that we have to counter that with the tail rotor and a set of pedals. So these are all linkages are all tied into the pedals on the floor. So when you rotate these, somebody's in there. They locked there. So that is actuated by the pedals to give it the torque authority to overcome the power changes that you make when you're flying the helicopter.
Okay. And if you could explain to all of us what is the uniqueness of having the vertical and a horizontal stabilizer on a helicopter?
So vertical stabilizers make sure the tail stays behind you in case of a tail rotor failure. So if you maintain a little bit of forward speed, about 30, 40 knots forward speed, there's enough authority in this to overcome the torque, so that you can land. Horizontal stabilizer, believe it or not, on this helicopter is more aesthetic. It just looks very cool, and everybody loves it. The designers said we don't really need that. We didn't have any pitching moment when you lost power, but it just looked wicked cool. So everyone asked for that. So this ship, and I think now the tandem plates both carry that tail as well.
All right, I'm gonna pop in here real quick to talk about our sponsors. As you know, I can't do this all on my own. We got to have somebody to help fuel that truck. We try really hard to work with sponsors that provide a good service and a good quality product. So let's talk about those guys right now.
Dynon Avionics at Dynon.com, the premier provider of glass panel avionics systems for experimental and light sport aircraft. And visit our website at experimentalaircraftchannel.com for new videos and easy to navigate playlists and so much more.
Speaking of fueling that truck, if you guys want to join us on our Patreon page, become patrons of this channel, just search on Patreon for Experimental Aircraft Channel. Sign up. There's several different levels, so check that out. All right, Keith, let's kind of jump into the helicopter here and talk about some of the flight characteristics and numbers.
Sure. So this helicopter you typically fly from the right seat. And that's most helicopters you could fly from either seat. This helicopter has a governor. So on the collective, which is the part that we use to actually pick the helicopter up into the air, this collective has a switch on the end, which is the governor to activate the governor on the engine. So on startup, when you first apply power, the right instrument on the panel here is the EMU, Engine Management Unit. And once that has power, it'll actually light up with what throttle setting to set to start the engine, because the engine's fully FADEC. It's an automated fuel, automated ignition, automated everything. So as soon as you roll the throttle up to where that turns green, it'll tell you what percentage, and it'll be in the wrong color until you're in the right range. As soon as it's green, you crank just like your car. You crank the starter, fires up. Once it's running, then you have a little bit of a warm-up period. As soon as it warms up, we usually roll the throttle up, put the governor on to check the governor, and then we go through a series of tests. So on the overhead panel, we have a set of lane A, lane B, which is for the Rotax engine to check the failover of the Rotax system. And we have 2 fuel pumps, so we check each fuel pump to make sure they're both actuating. And all of those things also indicate in the warning lights at the top. Once we've warmed up, we have no warning lights. Pressures and temperatures are good. We're ready to fly. So we take the friction locks off. So there's a friction lock on the cyclic. That's what moves us around, gives us the ability to roll and pitch the aircraft. And then we'll take a friction lock off of the collective here, and that gives us free movement of both controls. One thing I will mention is this particular helicopter has the optional cameras. So there's 360-degree view camera that displays on the left MFD, so you can actually see that the tail rotor is clear before you pull pitch, as we call it.
Awesome.
That's what it's called when you lift that collector, pull and pitch. And once you pick it up, like as I said, you'll get light on the skids to kind of sense where neutral is, and then pick it up into about a 4-foot hover. And usually I'll do a pedal turn just to look out to make sure there's nothing on this side, and I'll always turn to the left because that's where I need torque to overcome the engine. So I make sure I've got plenty of pedal authority to make a good turn, and if it's wind blowing or something, I can overcome the wind change in doing that. Once you have that, you don't really have to give it any more power or collective. You just tip the cyclic forward. So once we tip the cyclic forward, the disc or the whole helicopter rotates a bit and starts moving. And once it gets to about 15 knots, 20 knots, you'll feel a little vibration where it moves through what we call translational lift. And translational lift increases the efficiency immensely. So it'll accelerate very fast, and we stay low to the ground, typically 4 to 6 feet, until we get up to about 55 knots.
So does that mean that helicopters still can take advantage of ground effect as well?
It doesn't use ground effect, it's just you're trying to stay out of what we call dead man's curve.
Okay.
So a helicopter at low altitude, you have to get your forward speed up enough so if you had an engine failure, you could safely land. And so at a certain forward speed, you can start picking up altitude. Once you get above about 500 feet, you can actually slow down to a hover again, and you'd still have enough energy to be able to recover.
Okay, so once you're out of that zone, and you get up to altitude, what is a typical cruising altitude for a helicopter in this helicopter, and what speed?
Well, 50 feet to 500 feet. Usually I don't ever get over about 500 feet. We never fly over buildings, never fly over a house or a home or anything like that.
That low, yeah.
Stay away from that. And usually if I'm around areas where there are buildings, I'll stay above 500 feet anyway. But yeah, I live in northern Nevada, and we have canyons and a lot of public land, BLM, National Forest Service, and so maybe I'm 100 feet, 50 to 100 feet, and flying through a canyon is nice with something like this because you only need about 30 feet, and you're able to make the turns really easy, and you can always slow down. Unlike an airplane, you don't want to get in a situation where you can't climb out of a canyon. The helicopter, you just slow down.
So how fast can you cross country with this?
This is not considered a cross-country bird, but it is about 80 knots, so 90 miles an hour or so as a cruise, high cruise.
And how many hours in the air do you have then?
It's about 2.5 hours duration, so usually we tell people 2 hours, right around 200 nautical mile range.
All right, Keith, so we gave everybody a glimpse of what it's like to fly this and operate it. It's a kit, so let's talk about what it looks like as a kit as it arrives and how you'd progress through the kit.
Sure. So the airframe kit, it comes in a crate about 12 feet long because we have to accommodate the length of the blades, and about 5 foot by 5 foot. And that crate, we have the airframe is supported, the skids are in pieces, all the sheet metal's in pieces, the tail boom, the transmission, all of that's in pieces. The glass, or the cockpit, does come assembled with the glass in it, so we don't have to worry about mounting glass. And at the factory, on the production line, we get the color the customer prefers, so it's already painted. and pretty much any automotive color that PPG does, except the metallic. We don't do metallic paints normally, but
it comes already finished and painted.
Yes, pretty nice. And then we have about 5 different graphics that they can choose from, and they can also pick the color of that graphic in the production. What we do when we ship it is have all the pieces all very well marked, all the bags of hardware all very well marked. And in the quick build kit, we actually mount the wiring harness in the airframe, and we attach some of the ADEL clamps in the places they need to be with the bolts and the washers, so that it's easier for them than going to try to sort through a bunch of bags of hardware. That way you know you have the right part in the right place, that type of thing. But it's very disassembled. You have to primarily do assembly. There's a little bit of drilling on setting the tail rotor shaft. We have some holes that have to be drilled there, but we have a jig and a gauge that sets the right length for you, so you can't get that wrong. And then they'll drill it and deburr that hole. And then on this flashing down here, there's a little bit of riveting, but it's all cherry rivets, pull rivets. So it's very simple to using common pop rivet tool, basically, to put that together. So it's mostly common tools, a drill with a one-size drill bit and a pop rivet tool. A little bit of Loctite, because we do use Loctite. And the other thing that you always use on helicopters, or should use on anything, is marking paint. So you'll notice everything has a little mark on it, because if I mark things with marking paint, when I'm doing a pre-flight, I can tell if that's moved or not. And so literally every bolt or fastener in a helicopter, usually are safetying them as well with safety wire and lock nuts, but you also put marking paint on them, so you know.
So about how many hours would you suggest that it would take in reality to build one of these?
Yeah, so that's always a great question for our home builders, because they start these projects and never finish them, right? So this is a 200-hour build in the manual. I did the first assembly of this one from a kit with the English instructions translated from Spanish. It was the first time we used the translated instructions. It was 165 hours. Now, I'm familiar with ADEL clamps and aircraft hardware. People that are less familiar with that stuff, there's some tutorials at the beginning of the instructions to explain those things and how to safety things. And so orienting themselves for that will probably take some more time.
Yeah.
But 200 hours is pretty realistic, I think.
Okay. Not that any manufacturer or dealer wants to talk anything negative about that. I wouldn't say this is negative, but what would you say is the most trying part of the build that maybe somebody might call you and say, hey, how do I do this part, or could you come help me do this part?
Well, I'll tell you what it was for me, because there weren't enough pictures. Hopefully we have enough pictures now, but the wiring harness, when Rotax ships these engines, they ship it with this wiring harness, the EMU, and the fuse box. And knowing exactly where to run those and getting it right the first time was the most difficult thing that I had to do. And so I ran them through here, and I thought the picture showed them underneath the frame rail. Some did, some didn't. And when I checked with the tech rep, he basically said it doesn't matter, because I wasn't sure how close things fit around it. So
well, to some degree, especially back here, heat comes into play, and also like vibration.
Yeah. So that's the one thing you'll always do, is make sure everything's really well supported with to stress reliefs, and nothing's being tugged on or rubbed against or things like that. So, but yeah, I would say that's it. The rest of it's pretty straightforward. Weighing an aircraft, when you're finished with it, you have to do a weight and balance.
Yeah.
And there's a couple of methods. We actually have a fixture that mounts on the mast, so if you have a way of lifting it from the mast, you need a scale there, and then you'll put a scale back on the tail, and you measure the distance from the mast center line to this to figure out what that moment is, and you can calculate it that way. You can also put 2 scales under the skids, and with one scale on the tail, and you're balanced right under the mast. When you put those, you just use a piece of conduit on a couple of scales, and then you can calculate the empty weight and weight and balance that way.
Okay, well, kind of in closing here, to wrap this up, if you could clarify for everybody where this is being manufactured, because you explained to me kind of off camera that you were doing some manufacturing, Argentina was doing some things, and then you were doing final. So if you could clarify that. Yeah,
so 2 things. One is all the hardware and all the raw materials are U.S. aerospace suppliers. They don't use things from other places of the world. We ship the raw materials to Argentina. The factory's in Saladillo, which is just outside of Buenos Aires. About 65 people down there, and They actually do the fabrication components, and then we finish kitting them with the hardware and everything in the U.S. typically. For other parts of the world, we do send that same equipment to Argentina so they can kit for other countries. Now, unlike a lot of other companies, we don't spend the customer's money on anything but materials for the customer until the product is shipped in final stage. So it's escrowed in the United States for North American customers. We escrow that, and we only issue that as we're buying raw materials for the production project.
And since you mentioned money, that is a big question that people always get mad at me for not sharing. But today is July at the Oshkosh Air Show 2024. What is the kit selling for now, and what can you expect to pay to get it flying?
Yeah, so two things. One, don't look at the videos that some other people have published about prices, because that's a lot of that stuff's very old. It's clickbait stuff. But the actual price in today, in end of July, which we don't anticipate a price increase. This is $220,000 for the airframe kit. A new Rotax engine, which is the way we sell it, with everything to make it work, the instruments, and a comm radio. So you need everything you need to fly except fluids. So you'll have to put gear oil in the transmission, gas in the tank, coolant in the engine.
So this is probably the most complete kit ever, including, because most kits do not include the engine, instruments, paint, interior, and you're saying it's all there.
It's all there. So factory does the paint, you tell us the color. We order these, we're OEM for Rotax in the US, so we order engines specifically in the configuration necessary for this. And we have great success with the suppliers. They've been great. A lot of supply chain issues that people used to see or hear about are kind of all behind us now. We won't say they're always perfect. We're always chasing quality and making sure that we're getting the optimum product for manufacturing. So it's just been a great experience. The factory's awesome. The Sakari sons, Augusta's sons that run the company, have been great to work with, very supportive, and they're partnered in the U.S. company to make sure that we're making customers successful.
Well, that's all about the helicopter, but what if you need to transport your helicopter great distances for, say, an air show? Well, Keith has solved that problem too. In the next episode, we'll show you all about Keith's literal low-rider transport trailer. Until next time.